Hello and welcome to another video. This time you're probably thinking we've done all this work in Z80 assembler and everything's going just too fast. How do we slow things down? Well, here's a few tools to help you do that. As usual, the only things you're going to need are Nano and the assembler EZ80 ASM. So if we look at our code today, we're going to start with the same normal routines that we go through, setting up the display and setting up the program. The data we're sending off to the VDU this time is only simple. It's just going to display a label and an instruction of how to exit. And what we're going to do is just run through a loop counting up from 0 up to 255 and then looping round again. We're going to start by loading D with 0, and this is going to be our counter. And then inside the loop we're going to keep checking if anyone presses the escape key so we can quit. As we go through the loop, we're going to load A with what is in our counter D, and then we're going to go through the printing routine that we looked at in a previous video, simply to print the hex value of A onto the display. We're then going to increase D and then go all the way back round the loop again. Now, as this is an assembler, this will be pretty fast. Let's have a look at it on the Agon and see what it's like. I've already assembled it and loaded it, so if I simply type run, we can see here that it's counting up, but it is so fast we can't see what's happening. So we need to introduce some sort of way of having a delay. If we look further down the file, you can see I've put together a routine here. I've called it a multi-purpose delay. What it's going to do is delay for a certain period of time. We give it a value in A, but all we're doing is setting one bit in A, and that will determine how long the delay will last. It's doing that by using the internal clock counter. I won't go through the routine in detail, but what it's doing is checking the clock to see whether one particular bit of the clock counter has changed. Bit 1, for example, will change approximately 64 times a second, whereas bit 7, if that's set, it will change about once a second. So if in our code here in the loop we inserted this call here, we load A with this value in binary and then call that multi-purpose delay. This will do a delay based on that particular bit value being set. If we come back to the Agon, I've already assembled it and loaded it, so I'll run again. So this time we can actually see it counting. We've slowed it down enough so that we can actually see the digits changing one by one. Going back to our code, it's this particular bit that we set, the third one in from the left. That's known as bit 5, and according to our reference here, bit 5 will change approximately 4 times per second. And that looks roughly what we've got going on here. Hopefully this will be useful to use in your own programs if you find things are just going a bit too fast.